Alright, so yesterday we got through the stuff of factor by grouping. So now we're going to look at the quadratic form, so factoring the polynomial completely. Basically, it's just a more, I don't want to say difficult, but it's just got higher powers, I guess is a better way to put it. Probably not. Yep. Like, how do you feel about difference of squares? Then probably like a 7. Alright, so number 24, x to the 4th minus 25. Okay, so we're trying to factor this stuff as completely as we possibly can. Okay, so what do we notice about this? Okay, both things are perfect squares. Okay, what are the perfect squares? X squared and 5, so we can think about this as x squared squared minus 5 squared. Okay, so what form does that look like? What thingy? What did I just ask Lorelai if she liked? Difference of squares. So, all we do is we follow that formula using x squared and 5 instead of normally we have something like x squared minus 25, which would be x plus 5, x minus 5. Now, same thing, but it's with x squared plus 5 times x squared minus 5. 5, 4. Okay, so a lot of these are going to be special types. It's just going to be a little bit harder, I guess you could say, than the original. What? Yeah. No, because you can't do anything else with it. So if it was a number that you could do something else with, then we might have to factor it again because these being x squared. We could potentially end up with another difference of squares within that. However, in this case, we don't have another one because 5 isn't a perfect square. You never have to, but I always recommend it. Alright, 26. 3s to the 4th minus s squared minus 24. Okay, so 24 and 3. What does 24 factor into? 6 and 4. 3 and 2. 2 and 2. Okay, so I need combinations of, I have 3 2s and 2 3s. 2 gives me negative 1. Okay, 9 and 8. Which one's negative? Okay, negative 9, positive 8. I'm going to put the 9 with the 3 and then the 8 with the 24. No. You multiply. Everything is multiplied. So we have 3s to the 4th, okay, make sure we pay attention to what the variables are there, okay, the powers on them. Minus 9s squared plus 8s squared minus 24. And then what do I need to do? How? From what? Okay. Yeah, so I'm going to factor by grouping. Okay. So 3s squared leaves me with what? S squared minus 3. How about the other one? Take out an 8. And that leaves me with what? s squared minus 3. These match, so we're good. So then 3s squared plus 8 times s squared minus 3. Alright, I'm going to give you one to try. 36 m to the 6th plus 12 m to the 4th plus m squared. On your own. Alright, we have an answer? Alright, what do we have? Okay, so you needed to take out an m squared first. Okay, that gets rid of that stuff and it gets it down to something that we can factor. It's a perfect square trinomial, so that gives you the 6m squared plus 1, all of that squared. Alright, so let's see. The next thing we need to look at is finding the real number solutions of the equations. So we'll start with an easy one. 32, y cubed minus 5y squared is equal to 0. So I need to figure out what y is equal to. Ideas on how I would do that. Okay, take a y squared out. So y squared is equal, not equal to. Y squared times y minus 5, so what's left over, is equal to 0. Now what? I'm solving for y. Y squared equal to 0, y minus 5 is equal to 0. Okay, you set each piece equal to 0 and then solve for y. So y is equal to 0 or y is equal to what? Okay, and those are your two answers. Wait, what? Because it's a theorem that we talked about like a couple chapters back. Probably actually chapter 4. But where you set each piece equal to 0 when you have stuff being multiplied like that. Let's see, 34. G cubed plus 3g squared minus g minus 3 is equal to 0. What should I do with this one? Like how? Yep, you can do that. Yes, so you have two options here. Is this factored completely? Okay, so you can go ahead and set each piece equal to 0, or you could finish factoring it so it's factored completely. Okay, so you could have done it the other way, like where you said to go ahead and stop and you were like, set each piece equal to 0 when we were here. That's fine. Just remember you're taking the square root, so you have 2 answers. So the reason I said you might want to go ahead and factor it completely is because a lot of times we forget that when we take the square root, we need to have 2 answers. Okay. Let's look at 38. Alright, so 38, 5b cubed plus 15b squared plus 12b is equal to negative 36. Yeah, so I still want, yeah, we're doing the same thing. So I want to get b by itself, basically, or solve for b. Yep, that's a good way to start. Move 36 over, because I need it equal to 0 to start with. Which leaves me with what? 5 or 3? Yeah, this isn't a difference of squares, so we can just leave it. Because it would have to be a difference of squares for us to do something with it. It would be something like h squared minus b squared. Or numbers that are a perfect square, like 25 was listed earlier. So it's, 5 squared. What is it? And the question said, find the real number solution. So what does that mean? Get rid of it. You have to still show that you did it, but just like cross it out, showing that it's not a real solution. So then how about the other one? So that's the only one that's real. I mean, like on the last problem we did, there were 3 real solutions. So it just depends. Let's see. Alright, one more problem I want you guys to try, and then I'll give you guys problems to work on for the rest of class. Number 50. So these ones, so 42 through 50 say that you can use any method to factor completely, okay, meaning you don't have to use whatever they specifically tell you, although oftentimes only one of the methods will actually like really work, so just pay attention to that. Z to the 5th minus 3z to the 4th minus 16z plus 48. No, these are just factoring. Like once you factored it once. If you've shown your work correctly, you should have 4 lines, with the last line being your answer. Correct, not including the problem. Give a little bit longer and then we'll go over it. Four. Alright, give you about 30 more seconds and then we'll go over it. Alright. What do we get? Does anybody agree with her? Because if you were to go back and FOIL that, it's not a perfect, or it's not a difference of squares. The difference of squares, the key is the difference that has to have a subtraction in the middle of it. Okay, so you take z to the fourth out of the first two pieces to leave you with z minus 3. And you take negative 16 out to leave you with z minus 3. So those match. So then z to the fourth minus 16 and z minus 3. So this is a difference of squares that factors into z squared plus 4z squared minus 4. And then obviously we're still bringing down the z minus 3. And then z squared minus 4 factors into z plus 2 and z minus 2. And then the other stuff, you just bring it down. Which one? To this one? Because if I were to do that, it wouldn't come out to be z squared plus 4 when I refoiled it back. It's not a difference of squares. Alright, any questions about any of this stuff? Okay, so then your added homework to what you had yesterday, okay, so everything submitted all together is 27, 35, 43, 47, and 49, and you should have plenty of time to get this done. And then also, I don't know if anybody's interested in some extra credit on the quiz on Friday, but if you are and you want to work for it a little bit, I have a 10-question worksheet that you can do to get some extra credit on the quiz. Yeah, it'll be due Friday before the quiz. So you'll bring it in probably, I'll make a thing on Google Classroom for you to submit it.